This is a working model of a very small part of the analytical engine's memory store. As far as I know, it's the only one in existence. It stands about 16 inches high, 40 centimeters, and has somewhere around 200 parts in it. And it's all 3D printed, apart from some hardware. Here's a close-up of part of the mechanism. It's setting up now, and it's reading out a number, clearing memory, and returning memory. And I'll explain how that's all working in a little while. The analytical engine itself was never built. It was designed by Charles Babbage in the 1840s and then basically through to the end of his life. He never completed the design. He was modifying things and adjusting things. If it had been built, it would look something like this in Sidney Padua's cartoon. It's about the size of a locomotive engine. And to the left of the Babbage and receding into the distance is the memory store. And the circular section in front of Ada Lovelace is the mill. Numbers were retrieved from the memory store, and in the mill, they were processed with the arithmetic and logical operations, and then the answers stored back into the store or printed. This is a plan view that Babbage produced. On the right, we see the memory store in blue, and it contained two banks of 50 numbers. Each number contained 50 digits. And on the left in the circular section is the mill, where all the processing took place. The red rectangle is around two memory locations that could well be the two that are in my model. The core of the engine is this figure wheel, about 1.5 inches or 4 centimeters across. It is linked to a pinion that can go up and down, the brown gear. And behind that is a rack, the green rod that has teeth on it, like gear teeth. And this rack starts on the far right outside of the picture at the reader, because all the numbers that are going to memory have to come from punch cards. The rack moves across, and in this situation here, it won't do anything to this particular figure wheel. But if we lift up that brown linkage pinion, as the rack comes across, it will store the number that came from the punch card into the figure wheel. If the punch card had a number 1 in it, the rack wouldn't move very far. If it had a number 9, the rack would move a lot further. If we wanted to get a number out of the figure wheel, or just return it to 0, that green lever in the center there has a little notch at the back that will engage with an indent on the inside of the figure wheel. And it will go from its home position at 9 around to its 0 position at 0. And at some point, it'll pick up the figure wheel and rotate it and turn it to 0. And that's good, because we do need to clear out the memory store before putting in a new number. But if we brought up that linking pinion and again ran the mechanism around so that green business went from the 9 to the 0, then the figure wheel would rotate back down to 0 and give off its number via the linkage pinion into the rack. So the rack would move out to the right by the same amount that it moved in when the number was originally stored. Here's just a close-up showing how that green business works. And to make this happen, there's a vertical shaft that goes through the center of the figure wheels. And at each level, we just see the units here, but above that, there are tens, hundreds, etc., all the way up. And every one of those figure wheels has inside it this green disc with the little tab on it. And the green disc is locked to the vertical shaft. In the basement, there's a gear wheel and a linkage pinion and another rack. It's a control rack. And in this situation, when the control rack goes from right to left, it will rotate its brown linkage gear, rotate the gear at the bottom, and all the numbers above and all the figure wheels upstairs above that will all be returned to the 0 position, giving off the numbers into their racks, because there's a rack here for the units, tens, hundreds, etc. Here we see a picture of the model, the 3 digits, units, tens, hundreds, and 2 columns of digits. So we have 2 numbers stored in here. And at the left, we can see 4 racks. The top 3 racks are for the figure wheels. The bottom rack is for the control wheel. And the control section is down here. Now, all these parts in blue are made very, very similar to Babbage's original design. They're in the style of it, and they're about the same size, but they're not historically accurate. There are certain things you can do 3D printing that are difficult in metal, and some things in metal that are difficult 3D printing. So some compromises have to be made. Now, to get the numbers in, I didn't make a punch card reader. So I use 3 stepper motors, and they pretend to be card readers. And below that, I have another stepper motor that's pretended to be a steam engine driving the bottom rack. And below that, Babbage would have a control layer of hundreds and hundreds and hundreds of levers and cams and such. Cams are wheels that are set off-center. And as these wheels rotated slowly, because they're off-center, they would lift the shaft that holds those pinions in place. So that's how Babbage would have got the pinions to engage or disengage. I didn't do that. I made it simple. I used 8 servo motors. Servo motors are just small electric motors, which will go between 0 degrees and 180 degrees under computer control, or any number between that. You go from 60 degrees to 85 degrees, for example. The stepper motors I mentioned earlier are motors that will go in either direction, and they'll step around in very small increments. So you can do multiple turns and stop at any point you want. You can see stepper motors working in a washing machine. During the wash cycle, it does short movements left and right to wash the clothes, and later it spins to dry the clothes. And you can see servo motors working if you take a cruise, because the rudder on a boat is often operated by a very large servo motor. Underneath that, at the very bottom, is a set of electronics. I have 3 microcontrollers in a network, 1 controlling device and 2 peripherals. See it again a bit better close up, and you can see the 3 data racks above and the single control rack at the bottom. From the side, you can see the racks and their linkage pinions, which are in the lower position right now. This is a close-up of one of the stepper motors pretended to be part of the card system. It has a gear at the top, and it rotates, and doing so pushes the rack in or out, and the data rack is turned in an amount proportional to the number retrieved from the punch card. Here we see the whole thing from a distance, and I'm going to store a 3-digit number. The control rack is going across to clear out all the numbers in the existing figure wheels. Now the data racks are going across in preparation for the card reader. Their cards have been read, and they're moving out by different amounts. The amounts have been stored, and now they're returning to their home position. Here's a close-up of the 3 digits, units, tens, and hundreds from the bottom up. And I'll show that again. You won't see the racks moving, which is what's happening now. But there's the numbers being cleared out, so all the figure wheels are set to 0. Now the data racks are going out in preparation for the card. And the card's been read, so you can see the numbers stored, 428 into the figure wheels. This is another view of the mechanism when a number is given off, as Babbage would say, given off to the rack. The green mechanism rotates from the 9 to the 0 position. It rotates the linkage pinion and pushes the rack out. Trouble is, when that's finished, the figure wheel is at 0. We've lost the number that was in there originally. And we don't want to do that. So Babbage has solved that problem by making a reserve wheel. It's a mirror image of the figure wheel, and it hangs upside down just above the figure wheel. And the reserve and figure wheel are linked by this gear mechanism here. And the idea is that when the green lever inside the figure wheel rotates to bring the figure wheel back to 0, the motion will be transferred up into the reserve wheel. And then at the end of that operation, 2 things happen. The linkage between the figure wheel and the rack drops down, and that green bit inside the figure wheel moves up. So it's now inside the reserve wheel. And it goes from the 0 position back to the 9 position, which is its home position. And as it does so, it will give off the number to that funny gear on the right and put it back into the figure wheel. Yeah, it sounds a bit complicated, but look, it's easier when you see it happening here. So it's setting up. It's giving off the number. It's transferred up to the reserve wheel above. Now it's coming back, and it's been transferred back down from the reserve wheel to the figure wheel. So now everything is as it was. And I'll show that again. Transferring up, transferring down. Thank you.